Unit 10, day 3 notes. Let's take this rational function and factor. Okay, we are fully factored. Nothing cancels, therefore. None. Domain, set x plus 3 equal to 0 and solve. That would give you -3. So x cannot be -3. Roots, set x plus 4 and x plus 2 equal to 0 and solve. That would give you -4 and -2. So those are our x-intercepts. Vertical asymptotes, set x plus 3 equal to 0 and solve. X equals -3. Tangent or togetherness, here we do not have an example of that. End behavior asymptote, we are top heavy. Let's go look back at the original function, x squared. Now there's multiple x values on top. You're looking for the one with the highest exponent. So we're going to compare the highest exponent on top, x squared, with the highest exponent on bottom, x. That means no horizontal asymptote, but what is the difference between x squared and x to the first? Isn't it a difference of 1? Therefore, we have an oblique or slant asymptote, which we are going to need to solve for now. So take x plus 3, set it equal to 0, and solve. That would give you -3. Now we are going to use synthetic division. Let's take the top portion of this fraction, x squared plus 6x plus 8. And now let's do our synthetic division. Bring down the first coefficient. Now multiply. -3 times 1 is -3. Now combine. 6 minus 3 is 3. And -3 times 3 is -9. This is our remainder, but don't worry about the remainder. It does not matter here. Now we're going to bring down our variables. X squared becomes x. And this will no longer have a variable. So our slant asymptote is y equals x plus 3. That is our end behavior asymptote. Now, in order to find our y-intercept, you're going to plug in a 0 here, here, and here, and then do your math. Well, 0 plus 4 is 4. 0 plus 2 is 2. And then 4 times 2 would be 8 over 0 plus 3, which is just 8 over 3. Okay, let's begin plotting everything that we know up to this point. We know our vertical asymptote is x equals -3. So where x is -3, we're going to draw a vertical asymptote. And now I'm going to do my slant asymptote. Y equals x plus 3. Our y-intercept here is 3, up 3. If you were to set x plus 3 equals 0 and solve, that would give you -3. So that would be where it would intercept the x-axis. So I'm going to plot that dot. And then I'm just going to go ahead and connect those two dots with one another. Okay, so our asymptotes are taken care of. Let's plot any coordinates that we know. X-intercepts, we have one at -4, 0. We have one at -2, 0. And then we have a y-intercept at 8 over 3, which is somewhere at about 2.5. So right about there. That's what this is going to look like. Okay, let's move on to example 2. Domain, if you set x plus 2 squared equal to 0 and solve, that would give you -2. X cannot be -2. None of these factors cancel, so no holes. Roots, if you set x minus 3 squared equal to 0 and solve, you would get 3. Vertical asymptote, set x plus 2 squared equal to 0 and solve, and that would give you x equals -2. Tangent or togetherness. Now we have an example of both of these here. Anytime you have a parenthesis in the numerator that is being squared, you have tangency. That is going to occur at 3, 0. You set x minus 3 squared equal to 0 and solve. Now we are going to have togetherness. Our graph is going to merge at this parenthesis that is being squared. Anytime you have a parenthesis in the denominator that's being squared, you have togetherness. And that is going to occur at x equals -2. End behavior asymptote. This is even distribution, x squared over x squared. So look at the coefficients, which in this case would be 1. And then y-intercept. Looks like we have -3 squared over 2 squared, which is 9/4. All right, let's plot vertical asymptote x equals -2. Horizontal y equals 1. And now our intercepts, looks like we have one at 3, 0. And then a y-intercept at 9/4, which is going to be somewhere in between 2 and 3. Okay, now this one is going to look a little different from any of the ones that we have graphed up to this point. Just a little bit, not too much. So we know that they are going to merge at x equals -2. They're going to merge here. Like whoosh, whoosh. And then it's also going to bounce at 3, 0. So I'm going to take care of this portion of the graph first. It's going to bounce and then sort of return to the horizontal asymptote. And since we are merging at -2, the other side of the graph must look something like that. Okay, example 3. Okay, domain here, you have to set both of these equal to 0 and solve. So x cannot be -2 or +6. No factors cancel, no holes. Our roots here, 3, 0. Remember, you set x minus 3 squared equal to 0 in order to find your roots. Vertical asymptote, set both of these equal to 0 and solve. X equals -2. X equals 6. We have tangency. Look at the top, it's being squared. A parenthesis that's being squared. So we have tangency at x minus 3 squared. So I'm going to write that as an ordered pair. Now on the bottom of this fraction, we only have one parenthesis that is being squared. So that is where they are going to merge together. They're going to merge at x equals -2. End behavior asymptote. Notice here down below we have an x that's being squared and an x. If you multiply those two together, you get x cubed over an x that's being squared. So we are bottom heavy. Bottom heavy, y equals 0 every time. Okay, y-intercept. We have, let me write it down here. We have a -3 that is being squared. I wrote the answer. I'm thinking the answer. Over a 2 that's being squared. And then multiply that by -6. And this will reduce to -3/8. Took a while to get there, but that's our y-intercept. I'm going to start by plotting the vertical asymptotes. And now the horizontal. X-intercepts. And now y-intercepts. Okay, what we've learned up to this point in this class is that if we have two vertical asymptotes, we're going to have something that looks sort of like a parabola, and this will be no different. And then remember, when we hit that, we're bouncing. Since we are merging, don't forget, we are merging at -2. Here's where -2 is. So the other portion of this graph must look like this. And this one is also going to be a little different than what we've covered up to this point. The remainder of the graph would look something like that. Okay, move on to side 2. Okay, example 4. I'm going to give you the answer, and then I'm going to explain to you how I got it. They don't provide me enough room there. I don't like it, so I'm going to write here y equals that is your answer for example 4. And now I'll tell you how we got that. So our domain, look at the numbers. -3 and 3. That tells us what x cannot be. Those are the numbers we put at the bottom. And then obviously put them in factored form. Roots are 1 and -1. Well, those numbers go on top. And then everything else would make sense also. In behavior asymptote is y equals 1. Well, yeah, we'd be top, or I'm sorry, this would be even distribution, x squared over x squared, so y equals 1. And then if you solve for your y-intercept, you'd get 1/9. Okay, over here, we're going to do the exact same thing. I'll look at my domain first. What can x not be? Remember, in factored form, it's going to change to +2 and then -4. X-intercept, we only have 1 here. And that's your answer. Example 6, 7, and 8. I'm going to write my answer for example 6 here. Given a graph, we are needing to come up with a function. Here's what you're looking for. You're looking for where's the vertical asymptotes and where's the horizontal. The horizontal is not as easy to identify, but it looks like it's probably right about here. All right, so let me start with the vertical asymptotes. We have a vertical asymptote at -2. So on the bottom portion, that's x plus 2. We have another at +3. So in the bottom, x minus 3. And now what you want to identify is, do we have any x-intercepts? Which we do. We have an x-intercept here and here. So that's going to go in the top portion of our fraction. We have one at -3. And a number at 2. That's your answer. Okay, example 7. Let's look for vertical asymptote. Looks like -2. And then horizontal, looks like it's going to be 1 again. X-intercept there. And then also pay attention to the hole in the graph. That's an obvious clue. There's a hole. So I'm going to start with vertical asymptote first. Our vertical asymptote is at -2. So in the bottom portion of the fraction, it's going to be x plus 2. I'm now going to take a look at the x-intercept, which is at +2. So on the top of the fraction, that'd be x minus 2. Now look at the hole. The x value of the hole is 3. So we're going to have x minus 3 on top and x minus 3 on bottom, because if we have factors that match, they cancel one another out, creating a whole. And the reason why it's x minus 3 instead of positive 3 is because if you set this equal to 0 and solve, if you set x minus 3 equal to 0 and solve, you'd get positive 3, which is the x value of the whole. And now example 8. Do the same thing. Find vertical and horizontal asymptotes. Looks like we don't have any x-intercepts here, but we do have a whole. That's the answer. The whole is at -2, so therefore we must have x plus 2 on top and bottom. Vertical asymptote was at positive 3, so we must have x minus 3 in the bottom portion. For 9, 10, and 11, I'm going to work through these fairly quickly. It's pretty much the same thing as side 1. And I probably won't do much explaining here, just to give you an opportunity to try it yourself and then look at the answers to see how you did. Remember, you don't need the remainder. That's why I skipped that part. I just realized I made an error there. It's not y equals 0, it's y equals 1. So please disregard this here. It actually is not that. It's here.